What's up, everybody? Today I've got this Lexicon MPX1 multi-effect unit. These came out in 1996. Now Lexicon is known for their reverb. They are the kings of reverb. And this is a multi-effect unit, so it's got other effects on it, and we'll go over that in a minute. Now there is a problem with this unit, and we're going to try to fix it. Let's go over the controls real quick. You have input and output level controls on the front. Your input and output plug into the back. Here you have clipping meters for left and right channel. Then you have your display here for the preset number. These are three 7-segment displays. You have a 16 by 2 LCD that shows what the current program is, for example, or if you're changing values of effects, it'll show the effect value. Here are your 6 effects, okay, that including the reverb. Here is your mix to mix the dry and wet signal, your bypass and your patch. The dialer will switch the preset that you're on, and then you have your options, your system edit, editing your values for all the effects and all the other stuff that comes with that. Okay, so let's go over these effects. There's 6 effects right here that you can choose. These are actually effect categories. What I mean by effect categories is each one of these buttons is a category. So there's other effects under each one of these categories. So for example, if I click on chorus, then under the chorus there's an actual chorus, there's a flanger, there's a phaser, and there's 11 total effects under the chorus. I can't remember off the top of my head what they are. But each one of these has other effects under it. So there's a total of 57 effects in here. Now, here's the thing about this unit. There's 2 digital signal processors in here. There's one that handles all the effects except for the reverb. And then there's one just for the reverb. Okay, so the reverb has its own effect processor. Remember I told you these guys are known for their reverb? Well, they have their own processor for it. It's called the Lexi chip. So because of that, you can combine reverb with any other effect because the reverb has its own processor. But when you want to combine other effects together, you may not be able to because they're sharing another processor. So it depends what you're trying to combine. If you can't combine certain effects, it'll give you an error and tell you, hey, you can't do that. So you're limited on what effects you can combine. Only the reverb can be combined with anything else. Alright, another thing to note about this is that it comes from the factory in stereo. So this has 200 presets, and most of those 200 presets are in stereo. So that means they use both the left and the right channel. So if you're plugged in to one channel and one output like I am, I'm going into that amp right now, then you have to tell this, you have to go into system and tell it that you're in mono, and you have to choose left or right to tell it which side you're coming out of. Because what's going to happen is, since most of these are in stereo, you're going to be plugged into one, and you're not going to hear some of the effects because they're coming out of the other one also. So you have to go into the system and tell it to go into left or right channel mono, depending on where you're plugged in. Alright, so let's see what's wrong with this unit. I'm plugged into the right channel, okay, and I have the output turned all the way down, okay. My guitar is plugged in, the amp is on, so let's turn up the output and see what it sounds like. Okay, you hear all that static? There's a lot of static on the right channel. The effects work, the output works, the audio signal goes through with the effects, but there's static. Okay, so I suspect it might be an op amp, but we'll have to open it up and see. So let's take a look at the left channel now. Let me plug everything into the left and we'll see what's wrong with that one. So now I am plugged into the left channel, and let's see what that problem is. Okay, so there's humming on the left channel. Okay, the effects work, everything else works. It passes a signal, the effects all work. So I've got static on the right channel and humming on the left channel. So let's take it apart and figure out what the problem is.
All right, here is the block diagram. And here is the input circuitry, the filters, the op amps, before it hits the analog to digital converter. And then here is the output after the digital to analog converter. There's op amps in here also. Now the output level potentiometer that I was raising and lowering is located on the output, and that's what made the static get louder. Okay, the input potentiometer made the guitar get louder, but it did not affect the static. So I suspect the problem is in the output. It could even be in the digital to analog converter. Okay, hopefully we'll find it in, one of these op amps will be bad here or here. If not, then that means the issue could be somewhere here, and if that's the case, we'll have a really hard time trying to find it. So we're gonna start at the input, work our way to here, and then start here and go work our way to the output with signal tracing and try to figure it out. But before we do that, let's take a look at the schematic. All right, guys, here's the input section of the unit, and you have your left input right here and your right input right here. We're just going to concentrate on the left input because the right input is exactly the same. So basically, you have your input jack coming in here, or your XLR, or whatever you decide to connect. I'm connected with the input 1/4-inch jack. And you have your balanced and unbalanced switch, which is located in the back of the unit. So when you're in balanced mode, what's happening is your signal is coming in, okay, and it's going up right here, because it's not going this way because this is a closed loop because you're in balanced mode. But the bottom is also closed right here in balanced mode. So you have a version of the signal also going down like this and up in here. So this amplifier is a differential amplifier, and because these resistors here, okay, are all the same value, it's a differential amplifier with unity gain. So you're basically having a gain of 1 coming out of this amplifier. So now when you switch into unbalanced mode, then the signal goes this way, okay, and goes into the amp. And right here, because you're in unbalanced mode, the signal can't even get through here, okay? So then it becomes a single input amplifier, and there's an actual gain. I don't know what that gain is. I'm not going to calculate it, but that's how you get the balanced and unbalanced. The unbalanced signal has an actual gain from that, okay? That's how that works. Now, if you notice here, they have 2 diodes. That's a SOT23 package. That is the BAV99 package. And they have those everywhere. And what that's for is overvoltage protection. So basically, if your input right here goes above plus or minus 15, then it'll go into through the diode to the rails instead of going into your op amp and destroying your op amp. So they have these everywhere, and they're just for over voltage protection, okay? All right. Down here is the muting circuit. That's just to, when you first power up the unit, it mutes everything so you don't hear any noise when everything is starting up. Okay, we don't care about that. That's fine. All right, now here is your analog to digital conversion section, all right? Now, from the input pots, okay, notice here your inputs on the previous page, when they come in, they go here and then they go to the input pot, okay? So then on the next page in your analog to digital conversion, they come from the input pot, they go through an op amp, okay? And then they go in here, all right? And again, the right side and the left side are the same, so we're just going to look at this. So basically what's happening is it's going through this op amp and it's going into here, okay? And now this requires a differential input because there's a plus and a minus, so they're sending another signal, the same signal down here also, and it gets inverted, okay, and goes into the minus. So it's basically a differential input. So we're going to check right here, okay, for the left channel, and right here for the right channel going into the analog to digital converter to make sure there's no static. If we get static here, that's actually what we want. We want to get some static here because that means that our problem is either back here or back here on the previous page, okay? And that should be pretty simple to figure out because after this, it goes into the digital section, okay? Now, after the digital section, it comes out of here, goes through the digital to analog converter and gets converted back into analog. Now, we're going to check here also. Now, if we get noise here and we didn't get any noise going into it, then we have a problem because that means our noise is generated from the digital circuitry, and that's going to be really hard to figure out. Okay, I don't know if we'll be able to fix that. But if we have no noise here and we have noise here, then these op amps are bad. Okay, so that's basically how we're going to do it. And now this R out right here and left out goes to the pot. Okay, and then from the pot or potentiometer, output potentiometers, it goes through more op amps and then to the final output. So, you know, the problem could be here also, these op amps. Okay, so we're going to start first by checking the analog to digital converter inputs right here, because if we have noise here, we don't have to check anything here. Okay, we just go backwards and see where the noise is coming from. Okay, all right, so let's start with that. By the way, the other thing is this CS5360 analog to digital converter, the unit I have does not have this analog to digital converter. It has a different one, but the inputs and the other circuitry is the same. So we'll look at that data sheet to see where we can check that. All right, one more thing I forgot to mention is this circuitry down here. This is the soft saturation, and this is controllable through the front panel. You can either turn it on or off. And basically what this does is it's basically a clamping or a limiting circuit. So these inputs here, they require a certain voltage, let's say 5 volts. Okay, it could be less, but let's say it's 5 volts. So what happens is if these signals go above 5 volts, this circuit basically clamps them so they stay at 5 volts. Okay, that's all that does. And this is you can turn this on from the front panel or turn it off. By default, it's turned off, so we don't have to worry about it.
All right, so I took the cover off. There's 2 screws in the back and 3 screws on each side, and then you just pull it right off. Here's the power supply, and it's got a plus 15 rail, a minus 15 rail for the op amps, and 2 5-volt rails for the digital logic. Okay, now here is the Lexi chip that I was telling you about. This is the Lexicon's proprietary reverb digital signal processor. This does all the reverb. Okay, and then you have this Analog Devices 2115 digital signal processor that handles all the rest of the effects, all the non-reverb effects, basically. Okay, now here we have a FPGA that performs all the discrete logic. You have a Zilog Z80 processor here that handles all the system software. Okay, dynamic RAM is right here. Okay, here's your EEPROM that has all the presets and programs, and has also contains info for the Z80, the FPGA, and this digital signal processor here. Okay. All right, now this static RAM here is used by this Z80 processor to hold some, whatever variables it needs to hold. And it's also used by this as an audio buffer, okay? And it provides a channel between these two also, okay? I think that's it for the digital section. So the signal comes in here, okay, through U1. That's the op amp we saw in the schematic. It provides a gain when you're in unbalanced mode and has unity gain when you're in balanced mode. And then goes into the analog to digital converter right here, which converts it to digital and sends it out here to be processed and have effects added to it. Then it comes back and goes into this digital to analog converter right here. This is a Cirrus Logic DAC, and gets turned back into an audio signal, gets processed some more through some op amps, and goes out to the output, okay? Now, another thing is that static noise and that humming noise that we heard. When I put this in bypass mode, it still has that noise. So I suspect that the noise is one of these op amps. I don't think it's here. So what we're going to do is we're going to start by testing the voltages, make sure they're okay, make sure there's no ripple. Once we have that confirmed, then we're going to trace the signal coming into the inputs, and we'll see where the signal becomes staticky. And wherever the static comes, that's the component that's likely bad. So let's start doing that now. All right, let's check the voltages and see what we have. So here is the 15 volt rail. Okay, 15.67. Here's a 5 volt, 5.06. Here's the other 5 volt, 5.06. And here's the negative 15. Negative 15.02. So the voltages are fine. All right, guys, a couple of things I wanted to point out. I said earlier that there's two 5 volt rails here. There's only one 5 volt rail, but for some reason they got two red wires going to it, but it's the same rail. They just have two wires going from here to the board. I guess they thought maybe there's too much current and they needed two wires. I'm not sure why they did that, but it's the same rail, 5 volts. Alright, so here is the probe I'm going to be using. I made this myself a long time ago. It's basically a quarter-inch connector, and the tip goes to this tip on this side, and the sleeve goes to this ground clip here, okay? And this just plugs into the amp. And all this is a finish nail. That's all it is. And it's going in here, and there's a 630 volt 10 nanofarad capacitor in here. And the reason you need the capacitor is because we're going to be plugging right into the amp. Okay, so if we, in case we accidentally probe a DC rail or something, we don't want to ruin the amp. So the capacitor blocks the DC voltage. All right, so we're going to start probing this. Right here, that's the analog to digital converter. And now remember, we're going to probe the left in positive and minus, and the right in positive and minus. And let's start with the right, because that's where the static is. So let's probe this one first. Now, on this schematic here, okay, this IC is not the same as this one. This is the one that I have, okay, on here. And so basically the right side that we need to probe is, see, it's pin 24 and 23. It's a negative in right and positive in right. So pin 24 and 23 right here. That's where we're going to start and see if we get any static. Okay. All right. So let me turn the amp on. Should be all right. All right, now I'm not going to put a signal in. I'm just going to probe for noise, okay? So let's see, we said it's pin 24 and 23. So let's probe. This is 23. There's actually a test point for it, so I'll go on there. And 24. Yeah, I'm hearing the noise on 24. Okay, not on 23. All right, since we're here, let's probe the left side. The left side is, let's see here. Where is it? Okay, positive in left and negative in left. It's 33 and 32. And remember, on the left side, we heard humming. So it's 33 and 32. Okay. Let's see. This is 33 right here. All right, let me go a little louder. Yes. Hear that? 32. All right, so let's see. So pin 32 has humming, and pin 24 has static. So 32 is humming and 24 is static. So let's see. 32 is, where's 32 on here? 32. Negative in left, and 24 is negative in right. So the negative is what's causing this. So let's look on our schematic. All right. Let's see here. So let's see the minus, and so the inverted signal is what's causing this. So the minus right here, left, and the minus right, which is going, let's see, where is that going? Let's see, the minus, it's going into U10, okay? And the minus from here is going into U11. So they're different op amps. So I don't think that's the problem. It could be this circuit down here causing the issue for us. It could be our soft saturation circuit, but let's work on one at a time. Let's take the right, and let's go to, let's see, we know it's the minus, so let's go down here into U10 and check pin 7 on U10 and see if we have anything there, okay? You hear that? That's what's coming out of there. So that's the problem, okay? All right, so basically we have noise in here and coming out. So I think this op amp may be the problem. So I'm gonna take it out and let's see if the noise goes away after I remove it. Alright guys, I removed the op amp. It's right here, okay? And it was right there, U10. So let's turn on my amp. Okay, and let's see if I still have noise on this, on pin 24 and 23. Nope, no more noise. And let's check the pins where the op amp had the noise. Nothing. Okay. Nothing on the other side either. So I think it was that op amp. Now I don't have another one. Let's see. These are what are these? These are MC33078s. I'm gonna have to order some of these op amps and pick up the video when they arrive. All right, I've got the parts right here from DigiKey, and let's open it up, see what we got here. Okay. Let's see. Yeah, it looks right. Okay. So let's take one out and solder it in. All right, let me move this into view. Okay. Now I bought more than one. I bought 25 of these because I don't have any BJT op amps, so I might need them somewhere else. Plus, we might need another one for channel for the left channel because we don't know what's wrong with that one yet. So let's solder this one in to repair the right channel, and then we'll test it out, and then we'll work on the left channel. All right, let me get my favorite flux. Now, I do have some of this RMA flux. I've got this Kingbo, which is pretty good. I don't know if it's real, but it's pretty good. But I like this Radio Shack stuff, this stuff here. So, all right, let's put some on. All right, guys, I got my Strat plugged into the right channel. Let's turn it on, and let's see what happens. No static. All right, well, I don't hear any static. So the right channel is fixed. That was the problem. That op amp was the problem. So let's work on the left channel now. All right, so we fixed the right channel, and now it's time to fix the left channel. So let's take a look at our schematic again, okay? And now we're gonna go. Let's see. The left channel is, remember, it was the negative side that was causing the noise, the inverted signal. So that goes here into U11. Okay. So we're gonna check pin 7. and we're going to check pin 6. And now if we get humming on pin 7, we're likely going to get humming on pin 6 because of the feedback. So then what we're going to do is we're going to go here and we're going to check this point. And if we get less humming on this side of the resistor, then the problem is most likely this op amp. So let's start by checking pin 7 of op amp U11. All right, we're going to check U11. That's this op amp right here. Okay. And we're going to check pin 7 to see if we hear any humming. So let me turn the amp on. Okay, let's check. Yep, it's humming. All right, let's check pin 6. Okay, pin 6 is barely humming, so let's check pin 7 again real quick. Yeah, okay, so pin 7 is humming. Pin 6 is barely humming, so let's see here. So pin 7 is humming, pin 6 is barely humming because a little bit is going back due to the feedback. So I'm not even going to bother to check this point because I think this op amp is the problem. So we're going to remove this op amp and see if the humming goes away. All right, so I got cap down tape protecting the plastic. And here is the op amp right here that we're going to remove. Now I got my airflow on low and temperature on around 350 Celsius. So let's remove it. All right, let's put some flux on the board. All right, let's try to get the new one in there nice and straight. Okay, looks good. Let's solder it in. All right, guys, it's the moment of truth. I am plugged into the left channel and I'm going to turn it on. And let's try it and see if the noise is gone. Okay, fingers crossed. Let's see. I don't hear any noise. Put it louder. Yep, we fixed it.